couple of these 632 screws are just plumb broke off. This one was broke. That one was broken. This one, it's a Phillips head screw. There's one that's directly underneath the blower. You cannot get to it with any of God's normal created tools. So, long story short, I had to get out the vampire tool. And these are a pair of pliers that are specifically designed for grabbing the edges of nuts and screws and hardware and shit. It's either been broke off or is it a funky angle where you can't grab onto it. And I was able to back it off and then loosen it with my fingertips. So I got the blower disconnected. That's the white, the black, and the red wire that come off the edge of the RF deck over here in the corner. Got them disconnected. Jeez, sure got the screws jammed in there tight. So, see, this would be right. And this is going to be front. This is going to be left. Front. Okay. Not that I think it's going to make any difference, but it never hurts. Okay, I think that we're ready to take this off. And there's our RF deck with our step motors. Oh man, there's fucking screws rolling around inside the blower. Little 632 screw floating around in there. Oh, that's nice. It's got a flow meter interrupter on it. So there's a little vane, a little reed that sits inside the air path. And when the blower comes on, it'll click this little switch out of the way. And it'll allow the RF deck to light the filament. That's cool. Okay, well, I'll take this apart to get the screw out of there later. Here's our contactors, bottom side of our contactors. Step gears, indexing, step motors. Another contactor. Filament choke, rectifier. Huh. Very basic. Now, why does everybody hate on this thing so much? It's got stop switches and limitation switches that all they do is they cut the motors out. This is so basic. Okay. All right. Well, for your viewing pleasure, let me get in here and let's take a closer look at this. So remember, everything's upside down and backwards from what we've seen it on the outside. From the back, this is plug 1, this is plug 2. And plug 1 looks like it drives all of our stepping gears. Oh, that relay needs some work. There's some, got a broke wire there. So plug 2 handles all of our step motors. Almost bet money. Almost. I would almost bet money. Don't count that as factoid yet. None of our contactors look burned. None of the wires look chopped. I wonder why this thing came apart so many times. Yeah, plug number 1 is all of our voltages. Oh yeah, for sure. Here's our gray wires coming out. That goes over here to the indicator for the steps. The powers. The powers come through plug 1. Yeah, our blower motor, all that stuff is here. Okay. That just gives us a decent 1-over, I think. That doesn't look half bad. The big question in the conversation is the tube. I'm not going to lie to you guys. It does not take much to break the filament, and it does not take much to have a short. All right, let me bag all of this hardware, slip the RF deck forward, and where's the yellow lead go? Goes down, hits the loom, comes out, goes over here to our relay, our vacuum relay in a corner. Yeah, okay. Yeah, so plug 1's all the control operations, our power, our trips, our protection circuits, our stops, our motors, relays. All this does. This goes to the filament meter adjustment on this plug. Yep, let me bag and label stuff. So here we are in the top part of the control unit, the head unit now. These are our presets, which we'll come back to. You can hang this, not scratch or break anything. Okay, so there's a couple things in here that I think are sketchy at best. First off is this voltage regulator, and the only thing I can determine that it feeds is on one side of the operate, this relay here, or this switch here, operate standby switch. It feeds this red LED. There's a red LED on the front of it. It's not listed in any of the paperwork. And it says that, I mean, all I can determine is that's an operate standby indicator light, and it's been kludge jobbed on there. All the solder joints are on this power supply. This attachment point on this power supply are bad. This wire is hanging on by a thread, and that leg is cracked and broken, this third leg here. So that all needs to be redone. These are cold solder joints, and this leg is hanging on just, I mean, if I breathe, see, look, it's hanging on by a thread. The other thing I've noticed is over here, if we look down here, this comes from our RCA jack, this lead. If you notice that lead, there's exactly one strand of wire off that lead. And that's coming from our operate standby RCA. So a couple of the other things I did is I noticed that the screws that hold on the heatsink for the regulators, that's what both of these transistors are voltage regulators. It's missing two of the four, there's 4 screws, it's missing 2 of them. So I got to replace 2 of those screws. I already went ahead and I pulled the regulators out and checked them with our handy dandy atlas. One's got a HFE gain of 45 and the other one's got an HFE gain of 36. So those are both good. This has kind of got me tripped out, right? Now there's another switch. This is top switch. This is for the peak kit. And according to the manual, I'm supposed to install a Bird 4300-405 or 400. That's this peak kit, and it runs on 9-volt batteries. Now it says in the manual that I can supplement with the output voltage off of this unit to power the peak kit. I don't know. But I'll be honest with you, in the manual it says that you have the ability to add an auxiliary 16 presets. It's one sentence in one line that it says you have the opportunity to add 16 presets. I've spent the last few hours studying this manual and looking at how things are wired in here. I'll be honest with you, I don't think this box is going to integrate with this. I just don't. I think this is for a later model Henry 8K, and this is an older model 8K. And the reason I say that is there's a band switch selector mode. I've seen some pictures on the inner boob now. The band switch on the front's got 2 extra positions that this switch does not have. Number 1. Number 2, there's no dedicated plug for it. Number 3, in here is all the presets. This box, this metal box here, this is all of our internal presets for A through M. Okay. And it's A, B, C, D, E, and then M. And the presets over here, this would technically get us 16 if we added this. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I think the M stands for memory for preset, for the band selector. So 10 is a push button, by the way. We were talking about that just a few segments ago about the push button on the front. These other 4 segments are not push button. That is a push button segment. So I think what I want to do is I'm going to add those 2 screws that probably have 0 to do with the operation of this thing. I can almost guarantee you money. That's the case. I want to repair this PTT wire that's down to less than a pubic hair. I'm going to change how this voltage regulator is hooked up. And this is raw right off of the power supply. The power supply's got its own regulator. I'm also not going to lie to you. It is 3:30 in the morning. I've been going nonstop. My ex-boss called me in today and had me come down and help him at the fair, impound cars. We had a blast. Me and him literally had a blast. It's the first time we worked together in like 3 years. It's actually the first time I've been in a tow truck in about, well, towing cars anyhow. It's been a minute, right? It's been a couple years. So it was fun to saddle up and get out and go do that. I think what I'm going to do is I'm going to stop here for tonight. I'm going to go get a good night's rest. I'm going to get out here and I'm going to come hit this thing fresh tomorrow morning. And boy, there's little, if anything, I got to do to restore anything. I don't think the dude had this thing wired right, to be honest with you. I got to look at how the 220 volt mains are wired on the input of the amp. I got to look at that, and some of the things that I've seen that have been touched, they're just not, they're not right. Another thing is the RF deck. It's got a bridge rectifier, a bolt bridge rectifier, but in the manual they're showing a Zener, and it's the filament bias. But this brick rectifier they've got in the RF deck, I'll show you tomorrow, is blown wide open. I mean, it's wide open. And it's got one of the resistors is hanging out. There's a resistor that you use in the circuit to constantly allow you to have bias reference. So when you switch the bias on and off, you're never absolutely without ground reference on the center tap of the filament transformer. I find that that's odd that they did that in the RF deck. I got to verify that's what that goes to. And for that to work, I've got to get out the 20-foot umbilical cord there. Got it out. Jeez, it is time to call it a night. I got to pull that cable out and reinsert the RF deck and trace the wire out of the RF deck down to the center tap of the filament transformer. Because the manual doesn't give us, it gives us a pin out, but it's going to take a few minutes. It's just going to take a few minutes. It'd be easier just to clip onto it and plug everything, like slide the RF deck in, clip onto it, chase it down to the center tap of the transformer. And if that's the case, then we have no bias reference off the center tap that's switched. So that means the amp won't work either way. I've got to get a new one of those diodes coming, or use 4 10A10s and recreate the circuit inside the deck, but I want to keep everything as stock as I possibly can. So I've got to see if I can hunt that down. So a little bit of work in here. I won't know until I power this up exactly what I've got for voltages here. This is that power supply that just clicked in my head. My God. That is this supply. Literally as I was speaking words with my mouth hole. He blew this up, and he knew it. I'll be. And this is a later version. The heatsink fin is different, the capacitor design is different, the transformer's the same. Oh, what's the voltage on this cap? $16 volt, 222 UF. Okay, so I have 16 volts, max 16 volts. When I initially got in here, this whole control board was loose. It was hanging on by just one thread. So, well, I bet you this knocks the voltage down to 3.5 volts or 1.5 volts. I'm going to repair. Should I repair or replace? I think I'm going to repair. This would never work in there. This whole heat sink assembly and everything would have to come out. That would come off. Interesting. Very interesting. Well, this is a backup power supply that runs the whole frickin' control head unit. Well, I got some stuff to think about. Gentlemen, I'll see you tomorrow. So here we are the next day, and I think what I'm going to do is I'm going to change out this power supply. This looks a little hokey to me, so we're going to disconnect and replace this wire. We're going to disconnect this one. I'm going to disconnect the 110 volts that feed this power supply down here. I'm going to slide this out, and I'm going to put the brand new one in its place. Then I'm going to grab some voltage regulator units, and we're going to mount those up on the wall back here instead of just hanging out in free space to break off and cause problems. And I'm going to hand tie these wires and clean all this up. Hand tie this up and probably create some clips for this thing. This is what feeds the memory module, preset module per se, this unit, this wire here. Route all this differently. Try to clean this spaghetti mess up. So I've been looking at this. So this is the Bird 4305, and they want the 43400, which is a way out of date model. This runs off 9 volts. I think. I gotta verify if it's 9 or 18, but they want you to mount it to the back of this meter. And then you flip the power, so you'd leave this switch on. in and depressed. And then the peak kit operates standby, which is driven through this switch. All it does is flip the DC voltage on and off. So it pulls a common, you apply a common ground to it, and then you flip the regulated voltage on and off. So that's one of the things that we've got to create, is a regulated supply for this, which we'll do in a very orderly fashion that very much falls in line with Henry. So give me a little bit. When we get back, power supply will be changed out, the wires will be all organized. I am a little bit concerned about how this peak kit's going to mount up, because the way they have this set, I'm pretty certain I might have to build some standoff pedestals, or maybe remote the meter kit some other place. But if I bolt up to the back of these, I'm going to end up hitting the band control switch, which would be very bad. So we're going to play. I'm actually going to start doing stuff to this now. Like I said, we're going to repair this. So I'll probably bring it down with this loom, and then bring it around the way it should be, instead of just having it hanging in free space. I'm going to retie these lines here, so I'll bring this down and bring everything together so it makes sense. But yeah, it's time to start organizing. So I'm getting ready to put the new power supply in, and to do that you got to disassemble this whole heatsink assembly, because it goes on the outside of the case down here. And I go to pull off this transistor. I don't know how well this is going to come out on camera, but this insulator was folded completely over, and the transistor was going right to ground. Now it is an NPN, but I can tell it was never powered up. 52 on the gain on that transistor. If that thing would have been powered up, like if I would have not looked at that and powered that up, bam, would have been the only thing that happened. A big bada kaboom. Because the positive signal comes in on the body of the case. And then this gets grounded, the heatsink gets grounded. See this insulator that's in here? This insulator, that top one, was folded over, and so the transistor was snugged down to the heatsink. Boom. Boom is all that would have happened. Smoke would have come flying out of everything. It would, oh. Then I'd have to source those transistors. Oh, I don't even think about it. I'm so glad I caught that. Anyhow. So short of these 3 wires, which I'm going to pin up and hook to a transistor and a bunch of other stuff tomorrow, the on, activate, standby switch, completely redid all this, rewired all this, rewrapped all the white and pink and purple wires, redid the power wire leads, redid the ground and all these leads back here. And then on the front side of the cabinet, where it was a spaghetti mess, I went ahead and hand tied up all of this and organized and unsoldered and resoldered all of this. Now down here, hiding in the corner, is this blank all copper board. And I thought, man, what is this aftermarket garbage that's in here? Nope, come to find out, that's the blink control module that allows the meters to flash on and off as they're going through their tune function. So I went ahead and rewired all of that, and then I grabbed a piece of Teflon. I grabbed a bunch of this sheet when I was at Fat Boy 2 or 3 times ago. Anyhow, and created an insulator underneath this board, because everything is just flopping around. But tied all of this up, and short of these 3 wires, which to me look god-awful, and I'm going to completely change how they're wired tomorrow, this thing is completely redone. And everything is hand-tied, including the wires that fit this transformer. So I had a little bit of a hard time getting the regulators to go in. Apparently the heatsink is indexed, was assembled on there and put on there backwards, upside down and backwards, so, or upside down. The insulator was in there folded over. And then I had to reorientate to make the heatsink line up with the opening on the outside of the cabinet. Had to reorientate the transistor holders 180 degrees out and then reattach the transistors. Even the hot wires that come off of here, I've hand tied everything. Everything is tied up. Everything has its own harness. The power supply. Here's this weird thing I noticed when I went to put it back together. There's 2 extra screws right down here and another one right down here. Remember how the power supply was flopping all around in there? Yeah, it doesn't do any of that anymore because it has all the fucking hardware in place. Imagine that. So tomorrow, when I get out here, because this took almost all day to redo this. I know it doesn't look it, but this is a night and day transformation, and this is a lot more proper than what I was given when we started. Tomorrow we're going to focus on the peak kit. We're going to focus on our 2 voltage regulators and our on-off indicator, and we're going to start restoring the front. Like, we're going to hand wash all the display switches, we're going to check all the lamps, we're going to do all that kind of stuff. This is a full day, and it was worth it. And the entire time I'm doing this, I'm telling myself, I can just see a guy at Henry Radio, and this plug is at the jig, and he goes through and he solders on all 65 wires, let's say, and he's got a loom, and he just runs everything out on a jig, and he sits there and hand ties everything, and then he goes and he puts this in, and he's got to solder everything in. I'd like to envision that in my mind. These are all probably hand-built, one-off, bespoke, built by one dude at the company kind of pieces of equipment. But I'd like to imagine that, you know, some dude with a lab coat actually put this together. See you guys tomorrow. Perfect. Perfect. I'm tired. It's been a long night. So hanging out here on the back wall is our 5 volt voltage regulator that runs our operate standby LED. Yes. The way this was wired before was with a 5 volt voltage regulator instead of simply a resistor on the 12 volt power supply. That's regulated. I shit you not, but I think that was somebody else's aftermarket hack, but we went ahead and recreated it. Instead, I put it on the back of the cabinet, so the back of the cabinet can serve as a heat sink. Yes, it's on an insulator. Yes, it's got thermal compound on it. This is a 9 volt voltage regulator for something I added. So initially, I was thinking I'd do an 18 volt voltage regulator, or pardon me, 16 volt voltage regulator for the Bird 4300-400. But I don't know where they want me to put it, since the posts on the back of the meter aren't long enough, and the 4300-400 hangs down and it hits the band switches. So let me show you what I did instead. This is a modern equivalent to the 43-400, but at half the size consumes a quarter of the power, and it also allows us to have a multiplier. So now we have a peak kit installed, and it's fed by a regulated supply. I got rid of the blue but ugly switch that was on the front of this thing and replaced it with a new one, and I had to completely rewire the peak kit and had to build standoffs. That's what you guys saw me soldering together, was these little standoffs. I took a piece of copper, I created a spacer, I went and I got the appropriate actual thread size of a Bird 43 and not this screwed up, was it 440 or whatever size screw that makes up the back of this 30 UA meter. The posts are spread too far apart for a Bird 43 400 or 43 404 or 43 405 or the 43 406, all of which I own. None of them will fit. That and all of them are too long. They make contact with other things. I would have had to create some journals and build spacers and a whole bunch of other shit. So what I did as a compromise is I built these standoffs. They're made of brass, and you have your two posts for the meter, and to make them work, I had to build a standoff that came out this direction and went forward, another one that came out and went this direction. They were off by about just that much. Just enough that if I went to drill the board, I would have cut a trace and would have ended up screwing up the peak kit and had to even do more solder work. So this thing is now fully on the accurate side of things for the peak kit. It's not powered up, but it has been tested. And we went ahead and we added some new labels on the front. So we've got peak and average RMS, however you want to refer to it, Bird. And now I want to move on to the front. But for me to move on to the front, I have to finish the peak kit. But I wanted you guys to see the inside of this. It turned out absolutely beautiful, and it was worth all of my times to sit here and replace the power supply and rehand tie all the stuff that had been butchered by whoever had this before me and make it all the way back to stock. So if a guy wanted to, a guy could take all of this out of line, undo the finger screws, and yes, these are knurled finger screws, take this off, take the spacers off, and just hook the wires back up. And there's no damage to the amplifier other than what was already previously here. Zero. So that was the best solution I could come up with, and I think it works great. I'm really ready to move on. I have spent 2 straight days inside of this control head unit, and I know it inside and out. And if you called me with a question, I could probably tell you down to the resistor value, color code, and the wiring code of the deck at this point, because I've spent so much time with literally my hands and my brain inside this box. So let me put the pre-selector band selector back on, and we're going to put the lid back on it, and we're going to start working on getting the face all cleaned up. Okay, so this is really simple and kind of cool, I thought, and I managed to do all of this without drilling no holes in anything. That's what makes me happy. It really degrades the value of things, in my opinion, my humble opinion, when you start adding holes. Like, I can almost guarantee you these aren't stock labels, but I know if I take them off, the paint underneath is going to be discolored. At least I'd believe it would be. I don't know, I might take these off. Somebody else added these. It's like, this is a stock switch, and that's the reason I felt comfortable with adding a peak kit switch, because it's stock. But what I did is, for the peak kit, because it's got a multiplier in it, you can open the door, and built on a shelf in here, we're now in 1x, that's 2 times, and that's 5 times. So in theory, this peak meter can read up to 25,000 watts peak now, in a 10,000 watt slug. Pardon me, that 10,000 watt slug that's in this thing can read up to 50,000 watts or whatever, but whatever. Okay. But we now can reach back here with our finger and flip the peak kit to its different multipliers without affecting any of these other presets. So I thought that was pretty slick. There's no holes, and the guy could totally convert this thing back to the point where nobody would even be able to tell that I'd modified anything. And that's the way I'd like to do it. Another thing, I have checked every part. I've checked every gauge. I've powered up the power supply And our LED definitely does work. The forward and reflect does work. The plate amp meter, the whole switches, they all work. And the memory band selectors all work. The things that have left to be tested are the power, our sideband CWR voltage switches, which I pray to God that Jennings vacuum relay that's in there is good. I even checked continuity on the 10 and 15, so I know this is working. I haven't checked any of the LED lights. Everything else has been checked. And the other thing I was really thinking about modifying was this here. So this is our 10 turn. Scroll down one. So that one's set on 0. This is our 10 turn counter. And I was really thinking about taking this apart and eliminating, I want to go slow. These wipers are old that are in this thing. Making it so it's set on 1 instead of 0. So when we get up to the top of things here, nine, 10, it would go to 11. I thought that would be funny, but that's just my sense of humor. Quoting Spinal Tap, of course. The functionality of both of these 10-turn potentiometers has been verified, and they are tested. The operate standby switch, tested. PEP switch, tested. I didn't bother with an LED indicator. I thought about maybe sneaking it into the corner of the light, or the corner of the meter, or down here in the meter or something, and I thought, you know what? It doesn't matter. It's powered off the internal power supply. And I personally think the main reason that a lot of guys use that LED is to keep them from running their battery dead. Just saying. So, short of a communication error between this unit and the power supply, everything's good that I know how to test without putting voltage to it. So, we're done here. I want to change out this nut. If you can tell, probably can't because it's a little bit too dark here. This has got a little bit of rust on it, so we'll replace that. I've oiled the switch to make sure it'll continue working. And the other thing I need to do is de-dust the top of the panels displays. So I'll probably come in here and just shoot a little beautiful wax on the front of this thing, and wax on, wax off, wax on, wax off. 10 meters on, 15 meters on, 20 meters on, 40 meters on. These are your internal memory presets, by the way. And your band selector goes eeny, meeny, miny, mo, catch a tiger by his toe. If you manage to screw this up, you're a bigger moron than BBI could ever be. So, just saying, I got to get out my Bristol keys, and I'm going to soak these knobs and let them get all nice and clean again. Put them in, and then I'll pull them out and I'll pull them in the hydrosonic cleaner, and we'll get these all spotless. But I don't want to do a whole lot of rubbing on this because all the labels on it are perfect. Everything is still perfect. And I figure if I get in here and I start rubbing on things a little bit too hard with cleaners and solvents and whatchmahavs it and do's me do's, I'm going to end up wiping the labeling off of this or that or something. So this will take like 15-20 minutes. I'm gonna let these these three soak overnight. But when we come back, I think it's time for us to go check the remote cable and get that tested and certified and ready for us to use. And I think it might be time for us to jump over to the power supply. Gentlemen, take a minute and share this video if you can. My view numbers are slowly ticking down, and I can tell because YouTube isn't pushing my videos anymore. This is a big deal. This is the full length, let's take it all apart, let's look at everything on the inside of it video that's ever been put on YouTube ever about this amplifier, and this is the holy grail. So if you could, I'd appreciate it. And I guarantee you by the time I'm done with this thing, I'm going to know this amp inside and out like the back of my hand, which means I get to pass all this knowledge on to you guys. All right. So now I got to check the cable. This remote cable, I've had a lot of problems with Clinch Jones plugs in my life. And it all comes down to these connectors weren't silver plated or gold plated, right? These are nickel plated. We just kind of, when I hear people tell me, well, I got a Clinch Jones plug in between A and B and C and D, and this won't turn on or that won't work, I immediately go to, it might be a bad connection, right? 1, 2, 3, 4. 1, 2, 3, 4. So I get to sit here and I get to test every single one of these leads, which is totally cool. I enjoy this kind of thing, right? Interesting. So we'll take this plug and we'll give it a little bit of a, not a lot, just a little bit of a twist. Okay. So I look at this, and then I look at our modern amplifiers that we have today that are two-piece, which there's not very many of them made. And then I look at how this entire system is driven on the inside and how it's constructed. We've come a long ways in digital communication and compression. Like, we could probably do everything that goes on here with this multi-connection analog plug. We could get away with using a Jones plug in today's world. Or not, pardon me, not a Jones plug, but a Cat 5 plug. Because then we have a logic processor that sits in between everything and an encoder decoder. That kind of magic schmoo. That's the major thing that has changed between this amplifier and anything that's produced today. Good, we got a good solid ground. Good deal. There are some neat things that are out there today. Like, I would be surprised if in the next 3 years, 4 years, anything new has an analog meter in it at all. And we're not all completely liquid crystal display. Me personally, I'm not a digital kind of guy, but I'm saying that's the wave of the future. And I had a guy ask me the other day, if I was to buy a 3000 from you, what would it cost? And I told him, well, it's like 14,000 in parts. Just 14 grand in parts, right? And I said, what you'd end up getting, and that's without me charging any kind of labor, what you end up getting is a black monolithic box that you plug in, and it would run from just an app on your cell phone. He's like, well, how would I turn it on? From an app on your cell phone. Well, how would I tune it? From an app on your cell phone. Well, how would I, with an app on your cell phone? I laying in bed this morning, and I had to call my buddy Robert that runs Steam and Coax. These guys. Because I had an idea for a completely different meter other than this for version 3. We'll talk about that down the road. Ooh, that pin's loose. None of these are corroded, but man, that pin is loose. So, once again, we'll give it a little twist. So now by having this little twist, it allows me to have a visual, excuse me, allows me to have a visual indexing mark on things that I might think have a bad connection. Like this plug here will never see this plug here. It just won't happen, right? This one here is going to see the amp head, this one here is going to see the RF deck. But I can pull this off and go, well, I know that this plug here is loose because it's got a little bit, it's a very, I'm like, you can see it's just a slight twist. And then I can go and I can transfer those same twists and those plugs to the RF deck and to the control unit, right? Makes sense? I pulled the Jones plug cases off because I like to get a look at everything on the inside, make sure none of our grounds are broke up. I mean, they did these right. These are all soldered connections that have got heat shrink on them. So I can't give anybody a hard time about it. I mean, they did what they were supposed to. Hence the reason why we're here almost 20 years later and we're looking at this and it's still being a viable project. Now I'm on this, I've been on this now for 3 days straight, right? For me to spend 3 days straight on a project, it's usually a new build. It's just how important this is to me. If you sent me this amp to repair it, yes, I would do the exact same things to it that I'm doing to it here on video, because you have to. This isn't something that you can half call in. You have to be vigilant. I think of all the different things I've eliminated and a few things that I found that are a little bit wonky by just looking at things without actually plugging nothing in, without powering anything up. So I want to take and shove this inside of there. Just like so. I've been kind of teasing some of the guys on Facebook with the idea that we are right on the edge of a meter revolution in this hobby, this industry. I mean, we're just, it's in its infancy at this moment. But there are some really neat digital meters that are being created on the watt meter side and on the metering side. My friend, also kind of a closet student, ex-electro, all the boxes he's building now, he's found these little programmable meters that are completely digital and you can set them up to read multiple different things. And I applaud him for that. He is striving forward. He works a lot with my friend Nick, 757. Both of their base boxes that they're using, that they are building, all run with digital meters. I think the time is coming to where we're finally eliminating the analog meter way of thought. But I'm here to tell you that's a dangerous step, if you think about it. The main thing I have found, let's take my analog volt amp meter. This thing, for instance. I put that in there about 8 years ago. And in that amount of time, the old meter I had in there, which was LED, which I thought they would support forever, when it started having problems, I played hell trying to find another volt amp gauge that would fit in that same hole, that would show up on camera, because they no longer made that LED meter. So the question is, how long is most of this stuff supported, right? So this has got to go around like so. Yeah. How long do you think most pieces of equipment are supported in this hobby? I mean real. Like real numbers. Well, I can tell you that ICOM, Kenwood, Alinco, Yazoo, all of those guys, they'll hold on to something for about maybe 8 to 10 years is the product support, life of the product. That's how long they'll keep inventory of the displays, and that's how long they'll keep the boards, the amplifier section boards and the tuners and that kind of stuff. But they'll only probably do maybe a 2 or 3 year run in parts. The rest of it sits on the shelf until those supplies are used up. Right? We got really spoiled with Ameritron. Ameritron would support stuff for ever and ever and ever. I mean, I think they're still down there trying to sell off most of their parts inventory. Right? But when that's gone, now it's no longer supported anywhere. The parts become unobtainium. So if you do an amp today, with a digital meter, how long are you going to be able to support that digital meter? To where if somebody has a problem with that meter, let's say that a part of the screen burns out, or are we going to be sitting around in 15, 20 years talking about, man, it'd sure be nice if I could get my ACOM amplifier working. It's a shame that they don't make the display or the finals anymore. Or what? Think about that. Just food for thought. Let's go play with the RF deck for a minute, because I got to get some things in my mind un-effed in the RF deck a little bit before we can move forward any further. I got to look at the RF deck, and then we're going to start playing with the power supply. Because the next major step I want to get to is I want to get the power supply hooked up without the RF deck in the cabinet, by the way. And I want to make sure that the console and everything turns on, right? I think I explained in a previous segment how we're going to go about doing that to make it safe, so I can have the power supply like up on the table working on it, right? And have everything plugged in and still be able to run the control interface and make sure that we get it so it can turn on and turn off, and I got all the contactors making contact in the way they should. Okay, let's reset one more time. Okay, so now we're in the RF deck, and I can't help but notice I have this bridge rectifier that is completely blown open. So, what I need to do is I need to get in here, and this has been reworked a couple times. Like, a couple times. What I need to do is get in here, figure out what's going on here. I need to pull this, get this all broke down. I should have done this a couple days ago. Need to get this pulled, and I got to get the part number off of it. I'm sure I could build the exact same thing with some 10A10s, but oh yay, more thermal compound, yay. Can't seem to find this part number in the schematic. A 18050. I know this part. Seen it before. Okay, let me get the thermal just cleaned off my fingers here. While I'm in here, those inductors are good. That diode's good. That diode's good. That diode's good. Let's check our Zener here. No, okay. Good. Checked all that the other day. Checked all the coils on everything. Check the wiper indicators, those are good. That's it. Okay. Well, let's go see where I can get this part from. This guy. Wow, they used a lot of thermal compound. You know, a little bit goes a long ways, y'all. So there's a diode between here and here, and a diode between here and here, right? All right, let's go track down this part. This is interesting. What it's telling me here on the computer is that this part number doesn't exactly match, but this is an 1800 volt. Man, that can't be right. 1800 volt, 50 amp. But then when I back up to the previous search, I love how AI is able to put all this together for us. This is the one few things that I enjoy about it. The 1805 appears to be referenced discontinued high voltage rectifier block formerly sold by RF Parts Company. While this company is no longer manufactured, several modern equivalents are available for the high voltage rectifier current applications. So the suggested high voltage replacement for this is the MRD 10,000. Rectifier block with stud slots. So this is a standard 1000 volt half amp diode, or 10,000 volt bridge rectifier. Okay. And they want $95.91. Well, that's something. Sitting around here, I've got a tray. Where is that tray? I've got a tray full of these things. Hold on a second. It was a huge amount of work to find this one tray. This tray is full of all these old unobtainium rectifiers, right? These are all 12,000-ish, 10,000-ish. Supposedly. But the ones I'm interested in are these, and this is what I remember seeing in this box. So these here though, I gotta check the specs on these, but this might work just perfectly. Even though I know I'm gonna end up buying the RF parts part, it doesn't matter. I had to go look. Give me a second. So I think I got this worked out. This right here is our diode that's in question. It's D101, which translates to the cathode bias. This is our bias diode. EMI 12105-408. And that is so old of a part that Google over here on this side of the screen, you guys can't see it, doesn't even have a cross for it. So look at the direction that the diode's facing. This resistor here, this R103, is a 220 ohm 2 watt resistor. This is our fuse at the back of the cabinet. This is our relay, and then this R101 is a wire wound, no, pardon me. This is a 10K resistor, but it's supposed to be wire wound, and it's supposed to be 10 watt, right? An R102, 130 ohm. Okay. So let's look at which direction this is feeding. There's supposed to be a capacitor across this too. C122. C122/28. Ceramic disc 0.01. Okay, 1 kV. No big deal. All right. So let's go back over here and let's look at what we took apart. So this is the way this rectifier brick was installed. Please note the way the diodes are faced. Okay? Across these two poles, we had this $10K resistor. It's too low in watt value, right? but it looks the part. And then we have these two 0.01s that were on both sides of the diode going to ground. That's one thing. So this wire lead here, this is blue and white, and this runs over and it goes to the switch, and this is our 10 watt wire wand resistor right here. Now over here in the corner, which you guys can't see because it's just barely out of frame, but right here is our blue and white wire again, and here's our 1.5 amp fuse. All right, and that's attached to this wire. So remember the way the diode's facing. Let's look at how the diode's facing, and then let's come back over here and look at the schematic again. Look at where the fuse is at. Look at how the diode's faced. So, I don't necessarily say that this is the appropriate diode for this entire situation, but I can tell you this. This diode was put in backwards. And that would explain why it was blown. And it would also explain why he probably wasn't able to get any power out of it, because you know you have your anode. That's the top part of the tube. And then the cathode, which is inside, and the only way that we have access to that is through the center tap of the filament transformer, which is down here. This tap right here, which happens to be blue and white, right here. So, the way they're running this is this blue and white wire ends up coming out on pin, I believe 6, but it's this one right here is where it ends up popping out. So it's coming out of here through this banana plug, this Jones plug, whatever it is, out of this plug, and the switch they have internal. The switch is here, it's the relay. So the center tap of the transformer wouldn't allow the electrons to go through the diode because the diode's in reverse. Wow. This diode's nowhere to be found, and I'm a little bit kind of not thinking this is the right part. If you notice, this is the hole here. This one here is the one that this diode was attached to. This diode, this hole here was covered up. The original one went from here to here. So I don't even think this is the right part. I really don't. Now, the rectifying brick that they suggest that I buy that crosses with this looks remarkably like and is the same footprint as the high volt rectifier that's down here. The high volt rectifier that's attached to this board. Well, let me stick my hand down in here. We'll line the base of this diode up. And as we can see, here's the top edge of the diode. There's almost 1.5 inches of space. Yeah, these are the 120257 rectifiers. These are Henry specific. Henry still sells these. So what do we do? What do we do? Well, I've learned over the decades that once you can't find the part, sometimes you got to go build your own part, right? Turn the gain down on the screen a little bit for you. I personally feel that I could build a little board with some little standoffs on a piece of red phenolic and put 7, maybe 8 10A10 diodes and achieve the exact same thing for the circuit. And that's really all this needs. All we're trying to do is get ourselves a little bit of voltage reference for the bias for when we put the tube into transmit mode and take it out of cutoff. You know, we're trying to get it up to like class AB1, but right at the edge AB1. We don't want to go too low in current because then we'll be in class C and it'll make the audio all messed up. I really want to put the exact part that's in here, but the exact part's nowhere to be found, nor can I find the data sheet. And I know how much voltage we're looking for, and I know how much forward current we're looking for out of the diode. I just normally get there with about 5 to 7 10A10s. This explains a lot to what the customer was saying. Whoever, I bet you he had a tube go bad at one point. He replaced, or he's not willing to accept. I almost am thinking that there's something wrong with this tube, right, at this point. But that doesn't mean shit until we test it, which we're going to do here in a minute. That friggin' diode's in backwards. Yeah, this is the back side of the diode string, and this is the front side of the diode string. And the way they had that diode in there was definitely 180 degrees out. So that's neither here nor there. Part's still blown, and I still got to make the box work. And it needed to be like this. I'm telling you, the $95 equivalent to this is going to be much larger. And there's not enough real estate in here. I mean, there's just two diodes in here. There's two submerged here and two that are submerged here, and they can create that higher voltage and the higher current load because of the epoxy-based body and then the metal body for the heat sink. Yeah.